right, so let's do another example of geometric distribution. So again, suppose I'm looking for a student at your college who lives within 5 miles of you. Again, you know 55% of the 25,000 students do live within 5 miles of you. So now you want to know what is the probability you need to contact at most 3 people. All right, so remember that at most. So if I say I'm going to give you at most $100, that means the most I'm going to give you 100, and I can give you anything less than that. So, and also a different way to think about this is how a lot of my 1401 students understand it. You need at most a 70 on the midterm to pass the class. So that means you need at most a 70. So just think of things that make sense to you, okay? All right, so again, I'm going to go in, and now I'm going to do 3, okay? So I changed it. So I'm going to do student, and I'm going to say B, or I'm going to do part B, geometric part B, just so I get it, okay? I'm going to do 1, 2, and 3. Again, don't do 0. Don't do 0. Please don't. Okay, so geometric part B probs, okay? All right, so now we're changing, and again, if you have questions, go ahead and you can go here and do whatever you need to do. All right, so I'm going to go back to, or am I not thinking? Oh, let me make sure. I've made too many videos today. Okay, so I go back to calc. Whew, long day. Probability distributions, and go back to geometric. So now I'm going to change it to cumulative probabilities. I'm going to use my event probability, but now look, I'm going to change it. Always make sure to change it, because if not, it'll write right on top of it and you don't want it to. Okay, hit OK. So now look what has happened. I've got new probabilities. All right, this is a really good thing to show people. All right. So the probability of one student is 0.55. It's the same as if I do the individual probabilities. So if I add 1, the probability of 1 and the probability of 2, I get over here this one. Why? The first part of this problem I did in the previous video, I'm doing individual probabilities of 1, 2, 3, 4. In this one, I'm adding, so I start at 1, and then 2, I'm adding 1 and 2, and then for 3, I'm adding 1, 2, and 3. So that's what's going on. That's the difference between these two. So let me go switch back, and we'll talk about what I got. All right, so you can see here, this is what I got. So the probability that you need to contact at most 3 students, or excuse me, 3 people, is 0.9089. All right, let's keep going. I'm going to do another one too. We're just going to finish this one up because it's not that long. All right. Assume the probability of a defective computer component is 0.02. Okay? Or in my mind, it's 2%. Components are randomly selected. Find the probability that the first defect is caused by the 7th component. Okay, I'm not talking about people, I'm talking about components. Kind of same thing. Let X equal the number of computer components tested until you find the first defect. X is going to take on the values 1, 2, 3, and the probability is going to, or P is going to be 0.02. So my distribution is X approximates geometric, and then I put the probability. All right, so let's go ahead and do this. All right, so it wants to know the first one. And again, I have the instructions here for you if you need them. Okay. I'm going to do, let's do component. All right, so I'm going to do 1, 2, 3, 4, 5, 6, 7. And I promise in this class, I'm not going to give you really, I'm not going to give you like 100 parts or something. That's asinine. All right, I go to calc, probability distribution, geometric. Oh, no, don't tell me that. Okay. Quit. Oh, it's mad at me because I already have that one. Okay, prob. Okay, and it does get mad about the labels. Calc. Here, geometric. Okay, probability. I'm going to change this to 0.02. That's what I'm going to change again. If you don't change it, it'll write on top of stuff and you could be confused. Hit it, hit OK. Boom. Okay, here's all the probabilities. I'm looking at 7. All right, I'm going to make it bigger when I keep going. Okay, So here I look at 0.017716. So the probability that the first defect is caused by the seventh component tested is 0.0177. Okay. And I have a slide and I show you how I got the mean and the standard deviation. Again, the P is 0.02, so I just plugged in. Again, when I'm doing that standard deviation, make sure to do it in part so you get the correct answer. All right, one more of this and then we're done. All right, assume that the probability of the defective computer component is 0.02. Components are randomly selected. How many components do you expect to test until one is found with a defect? Okay, this question looks really hard, but all you're doing is solving for the mean. Because I didn't want to know, and let's go back here and look. It was asking for the probability. This is not looking at that. It's looking at how many components do you expect to test until you find one with a defect. So it looks really hard, but it's not. It's just looking for the mean. So you do the mean and you get 50. So you would expect to test 50 components until you found the one to be the defect. That's all you're doing on that one.